Hello, welcome to the continuation of lesson 3.2. We are going to be looking at how to solve systems, but this time with elimination. So up till now we've done graphing, we've done substitution, now we're going to do elimination. So solving systems by elimination is best used when all the variables are on the same side of both equations. So something like, and this. Something like that would be a great time to use elimination because we have the variables on the same side of both equations. And to eliminate a variable, that's kind of what we're trying to do, elimination. We're trying to eliminate a variable. The coefficients must have the same, or be the same number, and they must be opposite. So if I look at these, I have coefficients of 1 for both x variables, but for this one, my coefficient here is 1 and then -1. So this would be an ideal situation for elimination because what we're going to do is we're going to think about I'm adding these two equations together. It's like I'm putting a big plus sign over here and adding them together and adding them straight down. When I do that, I would have 1 minus 1, which gives me 0, and that's going to cancel those out. But we're going to look at some examples. So we've got solve the system using elimination. Well, the first thing I'm going to look at are my variables. Or my coefficients, excuse me. So here I've got coefficients of 1 and 1, which are the same number, but are not different signs. Here I've got +1 and -1, which are the same number and different signs. So I can eliminate my y's. Because when I think about adding these together, I'm going to say, okay, 1x plus 1x is 2x. 1y plus -1y is 0y. They cancel each other out. Equals 10 plus 2 is 12. Well, that was super easy. Now all I got to do is divide by 2 on both sides, and I'm going to get x equals 6. But just like with substitution, I don't want just one variable, I need both of them. So I'm going to have 6 plus y equals 10, and that would subtract 6 from both sides, and y equals 4. So my answer would be 6, 4. But if I wanted to check my answer, I could plug in 6, 4 to both equations. And this one is not too bad. I can just do, 6 plus 4 is 10, 6 minus 4 is 2. So I know it works. Another way to check my work would be to plug x in for the second equation. So when I subtract 6, I get -y equals -4. And then divide both sides by -1. I get y equals +4. And so I got the same answer for both of them. So that's another way that you can check your work, either by substituting the variable, either by substituting the ordered pair into both equations, or by plugging in what we got for our first answer to both equations and seeing if we get the same number. Either way is a good way to check your work. Here's another system for us to solve. So if I look at my coefficients, I've got 1 and 1, 1 and 3. And my x's, they have the same number, but they're not different signs. For the y's, they're not even they're not even the same number. So I'm going to have to do some manipulation here, and I'm going to have to change one of these equations so that one of my variables will cancel out. Now, there are several different ways we could do this. It doesn't matter if I eliminate the x's or the y's first. I just need to eliminate a variable. So if I want to eliminate the x's, I need one of these to be -1. I'm just going to pick the first equation, and to make that first variable or that first coefficient be -1, I'm going to multiply by -1, and I'm going to rewrite it down here. I'm going to get -x minus y equals -7. And now these are the same number but different signs. So I get these cancel. Actually, these cancel. And then 3 minus 1 would give me 2y equals 11 minus 7, which is 4. So solving for that, I would divide both sides by 2. And I would get y equals 2. Picking one of my two equations to solve, I'm going to get x plus 2 equals 7. Oops, sorry, 7. When I subtract 2 to both sides, I'm going to get x equals 5. And then again, if I want to check that, I could plug 2 into the other equation as well. I would get x plus 3 times 2 would give me 6 equals 11. I just plugged the 2 in right here. And so then I'd subtract 6 from both sides, and I would get x equals 5. So since I got the same answer, I know that I did something right. All right, let's look at one more. Solve the system using elimination. So we've got 2 and 4, 5 and 10, but neither of these pairs of coefficients are the same number. So I can decide which way I want to go about solving this or manipulating it. I probably should multiply this equation by something. I want to decide first, do I want to eliminate x's or y's? What I usually do is look and see, okay, even if the numbers aren't the same, are the signs at least different? And so for the x's, the signs are the same, but for the y's, the signs are different. So that's one less thing I have to do, because remember, I need same number, different sign. So if I can check one of those boxes for those 2 requirements, I can say, yep, they've got different signs, then all I need to do is get them to be the same number. And so how do I get 5 and 10 to be the same number? There's actually 2 ways. I could multiply the first equation by 2. I could also, if I'm feeling really crazy, I could multiply the second equation by 1/2. But probably not very many of us are going to want to multiply everything by 1/2. And that's okay. We can multiply by 2. I usually would do it that way. So I'm going to multiply, and when I multiply everything, I mean literally everything inside the 2x, the negative 5y, and the equals 11. So I'm going to get 4x minus 10y equals 22. Now be very careful. Don't get going so fast that you make silly mistakes. We know that those cancel out. And some people would say, oh no, my x's cancel out as well because they're the same number. But remember that we are adding these. And so when we add those, we would get 8x equals 40. And then I'm going to divide both sides by 8. And x equals 5. Checking my work, I'd get 2 times 5 minus 5y equals 11. So 10 minus 5y equals 11. Or negative 5y equals 1. So y is going to equal negative 1/5. And some of us, when we get fractions, we kind of go, wait a second, and that would be a really good time to check your work. But if I check it, I would get 4 times 5 plus 10y equals 18. 20 plus 10y equals 18. And then when I subtract 20 to both sides, I end up with 10y equals negative 2. And if I divide both sides by 10, it looks like they're different answers at first because it's negative 2 over 10. But remember, if you simplify that, we do end up with negative 1/5. Couple of notes. So I chose to eliminate the y's because they had different signs. I could have also multiplied everything in the first equation by negative 2 and eliminated the x's first, and that would have been fine. Over here, I chose to eliminate the x's by multiplying by negative 1. I could have multiplied by negative 3 and eliminated the y's. Really, it doesn't matter which variable you eliminate first. You can choose which variable you want to eliminate. You just have to make sure that whatever you're multiplying by goes to everything, even the number that's on the other side of the equal sign. So let me know if you have any questions, and I hope that this has been a good refresher on how to solve systems by using elimination.